All right, as we get started today, want to give you some practice with proportions. We haven't done anything with proportions for a while. Quick refresher for you. A proportion is an equality of two ratios to each other. For instance, the ratio of 2 to 3 is the same as the ratio of 4 to 6. In fact, we would say 2 is to 3 is 4 is to 6. You remember this? But if I didn't know that 2 is to 3 is 4 is to 6, if I knew that 2 is to 3 is something is to 6, and I didn't know what the something was, then I could solve a proportion by cross-multiplying. I could say that 3 times x equals 2 times 6, or 12. And that's one way I could get 4. We also have what we call the equal ratio method, which is to say, well, 3 times 2 would give 6, so 2 times 2 would give 4. That would work most of the time anyway. But especially if we did word problems. For instance, if I said, I'm going to charge Joshua 50 cents for 2 pencils. 2 pencils, 50 cents. Then assuming I'm fair and equitable, and Lana comes in and she says, Mr. Dasky, I need 7 pencils. Okay, 7 pencils, how much would I have to charge Lana? Well, again, we don't necessarily need to write the word pencils per se, but we put pencils over money, pencils over money. And that's how we could set up a proportion and solve. You're going to do that on numbers 38 through 41 at the bottom of page 489. So turn in your textbooks to page 400. I'm dyslexic. Page 498, and do numbers. It's dyslexic with the letters out of order, because a truly dyslexic person like myself wouldn't know the correct order of the letters. So anyway, page 498, do numbers 38 through 41, and we'll have candy for the first one done with all the right answers. This is more in place of our review exercise today. Page 498, 38 to 41, write a proportion and solve. just about another minute or so to finish up these problems. I tell you what, for sake of time, because we do have a shortened period, let's go ahead and take a look at these, and we'll see how we did on the ones we got done. Number 38, how did you set up your proportion, Lana?
2.5 hours over 90 hours.
Okay.
And x over 6 hours.
All right, good. So you put hours over miles, and you put miles over hours?
I don't know, but I think I got the right answer. I don't think
Is that how we should set it up, though? No, they need to match, right? So it's fine to put the 2.5 over the 90. I would have probably put the 90 over the 2.5, but you'd have to put the 6 over the x.
I had that, but I guess.
Well, you have what?
I had the 6 over the x, but then
Why did you say x over 6?
I swapped it by accident.
Okay. Try to read exactly what you have on the paper. It makes things so much less confusing for us. Now, I would probably lean with Joshua. I would say 90 miles, because that's the first number they give you, in 2.5 hours, and I put miles over hours like this. But it's not wrong to say 2.5 over 90 equals 6 over x. Either of those is fine, because again, the important thing is that miles stay together, hours stay together. Hours stay together, miles stay together. When you cross multiply and solve, what do you get, Lana?
202.5. 215.
Ooh, so close. 216.
What?
216 miles. We'll cross multiply 2.5x and 6 times 90 should give 540, correct?
Oh.
We'll then divide away the 2.5 from both sides. And of course, you can't divide by a decimal, so we're going to make that 25. And we're going to make this 5,400. Move the decimal over one place in each case. 25 goes into 54 twice with 4 left over. 25 goes into 41 times with 15 left over. 25 goes into 156 times. So 216 miles should have been our answer. Let's take a look at number 39. How did you set up your proportion, Joshua?
I didn't do 39.
You didn't do 39. Okay, Lana, how did you set up 39?
I didn't do it either.
Oh, you were going down instead of going over. Well, let's set it up really quickly. What's the first ratio we should write, Joshua?
14 books over $24.
All right. And if we say books over dollars, then the next has got to be books over dollars. Which number do they give us, Lana? Lana.
X over 36.
That's what I asked. What number do they give us? They give us a number 36. That's a number. And that's money, so we're going to put it down here. We don't know how many books, so we're going to call that X. Good. A number is like numerals that we can read on the page. They're numbers. Okay? The number is 36. And we're going to put it in the denominator, the consequent rather, because it matches up with money. Books over money. We'll cross multiply here, the 24 times x, of course, 24x. 14 times 36 at your seats very quickly. I thought I had it in my brain and lost it. Yeah, I had it.
500. 500.
There we go, 504. I'm going to divide that by the 24. Let's see, how many times would 24 go into 50? 2 with 2 left.
Oh, 2.
And then 24 goes into 24 one time. So 21 books would be our answer for number 39 had we made it that far. Number 40, back to Lana. What was your proportion?
I have one yet, but 3 over something.
Go ahead and read the problem aloud for us.
At a town hall meeting, a vote was taken about building a new bridge. For every 3 people who opposed the bridge, 5 people approved.
Stop. What's the first ratio?
3 to 5.
3 to 5. And that is oppose to approve. Right? All right. So, continue.
There were 95 people who approved. How many opposed?
All right, so how should I set that up?
X over 95.
Perfect. 95 approved, so that's got to go in the bottom. The X is how many opposed. There's our proportion. You said you didn't have it yet. Did you have that? And what did you get for your answer, Joshua?
57.
57 people opposed to the bridge. Good. Number 41, Joshua. What was your proportion?
15x
No,
over.
proportion.
I mean, my bad. 15 apples over $4.50 equals 5 over x.
Good. And here's where I would use the equal ratio method. I'd say, well, divide the 3 out gives you 5. So let's divide the 3 out to get how much money? $1.50 for number 41, our answer.
What was 40 again?
57 was our answer.
Oh.
What do you cross multiply? 5x
465.
equals 285.
Divided by.
You had who?
I got 465.
Did you have 3 is to 5 is x is to 95? Because that's what you told me.
Yeah, I have that.
Yeah, 3 times 95 is 285. Just careful on the multiplication. Oh, Lana, cross multiply. You said 5 times 95. Not 5 times 95, 5 times x, 3 times 95. Okay, so cross multiplying there. You're going to get some practice with that in your homework this evening, I believe. Yes, you will.
Equal ratio.
On that one?
Yeah.
You could, if you knew your 17 times or 19 times tables, times 19 in both cases, that would work as well. All right, well, let's get back to what we were looking at yesterday. We started talking about factoring, right? Finding factors that were common, not just with numbers, but we could do it with letters as well. And if you flip back another page, I believe, to page 497, was it? You'll see that chart, remember, where we started taking a polynomial and identifying, well, here's a number that's common, here is a letter, or maybe some letters that are common, and here's what the common monomial would be. Well, I want to take you to this thought now. Suppose we took the number 24, and I said I want to factor it into 3 times something. Well, class, it'd be 3 times. How did you come up with the 8?
That's all the other numbers.
You've memorized that 24 divided by 3 equals 8, right? If I then took this then, xy squared. Now, of course, we know that's x times y, right? So x times y times y. But what if I said, I want to factor it this way? X times what? Well, obviously it's x times y squared. What if I'd said this is y times what?
What? Is it x squared?
xy.
What? Oh.
Because if you divide, just as you could say 24 divided by 3 equals 8, that's how you factor something. You could say xy squared divided by y equals xy, couldn't you? Lana, y times xy equals what?
Wait,
Lana.
what, xy squared?
xy squared. Don't overthink this. Therefore, xy squared equals y times xy. 3 times 8 equals 24. Therefore, 24 equals 3 times 8. That's easy, right? Don't make this hard. Now I'm going to take it a step further. What is 2x times 3x plus 5, Joshua?
6x squared positive 10.
Good. 6x squared positive 10x. And if that's true, then 6x squared positive 10x equals 2x times 3x plus 5. Right? What we're going to work on is, instead of multiplying a monomial times a polynomial, taking a polynomial and splitting it into 2 different factors. But first identifying what was distributed in the first place. What's the common factor? Well, we can see there's clearly a 2 in both values, correct? Both 6 and 10 have 2 in them. Also, they both have, going back to yesterday, at least a single x in them. So what we can do is essentially divide the 2x out. 2x times what? We'll divide the 6x squared by the 2x to get a 3x. And divide the 10x by the 2x to get the 5. And there's our factored form. Just as 24 can split into 3 times 8, or xy squared can split into y times xy, even a polynomial can split up in many instances into a monomial times some other polynomial left over. It's like doing the opposite of distribution, and it's factoring out a common factor. I want you to write this in the margin of your book on page 496. Factoring is division. Factoring is division. So really what we've been practicing with for the past several lessons, dividing out a monomial, we've been practicing factoring. The difference is you've always been given the divisor. And now we're going to come up with our own divisor. But it's not going to be hard. After all, what we did yesterday wasn't hard, was it? No. And so we're going to come up with our own divisor, and it's going to be that common monomial. And once we have the common monomial, we can divide it to show that it times whatever's left would be the factors of the polynomial. We've got several examples for you. Let's go ahead and look at these. Write these down maybe on a piece of paper. So get a separate piece of paper, maybe from the back of your book, maybe from your binder. These are not in your textbook, but I want to practice these with you. You do them with me. 25b negative 10c. The first thing we've got to do is figure out, well, what's common? What is the common monomial? And so we always look first at the number. And there should be a number that kind of pops off the board at you. 25 and 10 both have what number in them? 5. We don't have to prime factor them to figure out 5, do we? We can see that. Then we should look at the letters. Are there any common letters? No, they have nothing in common. Which means 5 is the common monomial. This is what we would have done yesterday. We're going to go a step further. And we're going to factor, just as 24 factors into 2 things, so this polynomial is going to factor into 2 things. A monomial, the common monomial factor, and whatever's left after we factor or divide it out. Remember, factoring is division. So what we're going to do is we're just going to divide by the 5. Well, when we divide this by 5, 25b divided by 5 equals 5b. Negative 10c divided by 5 equals
Negative
2c.
We're done. We factored the polynomial. Just like we could factor 24 into, 2 and 12, well, we could factor 25b negative 10c into 5 times 5 minus 2c. And this is our factored form. Write this on your paper. 14w squared negative 9w cubed. 14w squared negative 9w cubed. First thing we want to look for is the number. Is there anything common in 14 and 9? No. This is 2 times 7, this is 3 times 3, but we don't even have to prime factor to see it. They're prime to each other. Okay, what about letters? Are there any letters common?
At least the
W squared.
Yes, not just the W, but you're both right. W squared, because they both at least have 2 W's. So we're going to write down the common monomial. but it's going to become a factor of the polynomial. And we're going to use parentheses to group the other factor. Remember that factoring is, so we are now going to divide the w squared out of the 14w negative 9w cubed. Joshua, what do we get when we divide out the w squared?
For 14, 7.
Careful.
Wait, divide. Oh, 2.
Right. Joshua.
Wait, what?
14w squared divided by w squared.
W squared.
Want to help him?
Just 14.
14. The w squared is canceled. All right. All right. Now, Joshua, for redemption, Joshua, negative 9w cubed divided by w squared.
9w.
Sign, number, letter?
Positive 9w. Negative 9w.
Negative 9w. Now, here's the one way, and there's our factored form. This polynomial factors into this times this. Now, what if we wanted to check? We're like, I don't know, did I do it right? Well, how would you check if you did this right? You'd say, well, is 2 times 12 really 24? Yes. Is 5 times 5 be 25, be 5 times negative 2c, negative 10c? Yeah. Distribution would be a way to mentally check this. So, Joshua, as we check, does this check out? And there we go. We can actually check our own answers as we go. Write this down. 2x squared negative 6x. What do you see that's common? First of all, number, Anna?
2.
Ah, there is a number this time. What about any letters?
X.
They both at least have one x. That's my common monomial. That's factor number 1. Now we're going to put factor number 2, but it's going to be a polynomial, so we're going to put it in parentheses. And to figure out what this is, just like I would say, 24 equals 2 times what? You'd have to mentally divide 24 by 2 to get 12. So we're going to divide the 2x squared minus 6x by the 2x, Lana.
1x negative 3.
Now let's check. If I were to distribute, would it check?
Yes.
Then I have factored correctly, and there's my factored form. Do you see what we're doing? We're taking one polynomial, and we're breaking it down into a common monomial and a remaining polynomial. How about this one, Joshua? 10x cubed, positive 4x squared, y. Do you see any numbers common?
A 2.
2. All right, do you see any letters common?
X squared.
X squared. All right, so there's our common monomial. Now in parentheses, we're going to write down everything that's left over once we have done what, class? Divided, because factoring is division. We're going to divide this thing by the 2x squared. Joshua, what do I write in the parentheses?
5x positive 2y.
Perfect. And if we distributed, sure enough, it would work out perfectly. These are the factors of that thing. Just as 3 and 12 are factors of 36, just as 4 and 9 are factors of 36. So 2x squared and 5x plus 2y are factors of 10x cubed plus 4x squared y.
The whole thing.
This and this are your factors.
Oh.
Yep. These are your factors. So just as we could split this up into a couple things, we're splitting this up into a couple of things. One of them's a monomial, one of them's a binomial. That make sense? How about this one? This is a little bit weird. Seems innocent enough though. 18x squared plus 6x. Lana, what's common?
A 6.
Good. She could have said 2 and she would have been right, but it's not the greatest common factor. She could have said 3. That's greater, but it's still not the greatest. 6 is the greatest number. Any letters?
X.
Good, and only x to the first because although this has more, that one doesn't. So 6x is the most we can take out. Take out meaning divide out, factor out, and Lana, what do we get as we divide out?
3x positive 1.
Perfect. Not 3x and then these cancel. They do cancel, but remember, whenever you cancel with division, it leaves you with a 1, which is important because if you didn't have that, you couldn't distribute to get this again, right? And the distribution is your quick way of mentally checking. Yes, that's 18x squared, that's 6x, there's my factor. So maybe make a note. As you factor, if something cancels completely, remember, put the 1. Basic rule of thumb, if there's 2 terms here, there better be 2 here. If it were a trinomial here, there better be a trinomial here. Let me have you try some of these in your textbook, page 497. Do 9 through 15, the odd. Page 497, doing 9 through 15, the odd. Good. Good. Do you need a tissue back there? Why don't you come get a tissue? That looks like a Hoover vacuum. And just throw your tissue away and go back to your seat. All right, let's see how we did here. Number 9, Lana, what'd you get?
7 parentheses 1x positive 1y.
Good, 7, and then in parentheses, x plus y, or we could say 7 times the quantity, 1x plus 1y. How about number 11, Joshua?
4 times the quantity, 7a negative 8b.
Great job. 4 times the quantity, 7a negative 8b. Number 13, Lana. Okay, what's the...
X times the quantity, x.
You're dividing an x out of the x cubed, so what are you left with?
X squared.
Mm-hmm.
Positive x.
Mm-hmm.
Positive 1.
There you go. X times the quantity, x squared, positive x, positive 1. It's easy. Don't overcomplicate it. And Joshua, number 15.
X times the quantity, xy positive 1.
Good. X times the quantity, xy, positive 1. Good to go on
I
those?
didn't do 15 because I was stuck on 15.
Okay, does number 13 make sense now?
Mm-hmm.
All right. And again, the idea is if you can distribute back to get what you started with, you did it right. Do the evens now, 8 through 16. 8 through 16 even now. No, he's not.
Can't get anything.
Which one are you on?
14.
There is something common. What is in every single term?
Oh, an F.
Yep, so that's what's common.
I forgot what it was.
All right, let's see how we did on these. Lana, we'll start with you this time, number 8.
3 times the quantity, 1x negative 1.
Good. 3 times the quantity 1x, or just x, negative 1. Number 10, Joshua.
2 times the quantity 1n positive 2p.
Good. 2 times the quantity n, positive 2p. Number 12, Lana.
3 times the quantity 2x squared positive 6x positive 3.
Good. 3 times the quantity 2x squared, positive 6x positive 3. Number 14, Joshua, you figured out that it was?
X times the quantity 2a positive 3b positive 5c.
Good. X times the quantity 2a positive 3b positive 5c. Here's a really good example so you can visually see this. You know, in distribution, we give a little bit of x to everything. Or we just give a little x there, give a little x there, give a little x there. Factoring, you're taking the x out of everything. So when you take that x out, you strip that x away, you're left with the 2a, the 3b, the 5c. Kind of see it really well right there, but you're pulling something out and bringing it out to the front in a sense. And then number 16, Lana, what did you pull out to the front? C, and in parentheses you were left with?
5c positive 7.
Good, so our answer was C times the quantity 5c positive 7. Questions on that?
What was number 12?
Number 12 was 3 times the quantity 2x squared positive 6x positive 3.
Okay, I got it right.
All right. Questions on this? We're going to practice more with this when we come back tomorrow. For homework this evening, though, I need you to do page 499. Page 499. The homework, numbers 1 through 11. Page 499, the homework, numbers 1 through 11. And also 20 and 21. 1 through 11, and 20 and 21. So you get a little bit more practice with those proportions. All right, you are dismissed. Have a wonderful rest of your day.